All right, how's it going, everyone? So today is going to be the second stream where I work on the compiler. Um, and so for anyone, I'm gonna talk for the first minute or so just so we can let some people join here. But for anyone that didn't join in on Wednesday, tuning in for the first time, the technical content here is not going to be sort of beginner compose work, and it's not even advanced compose work. It's unrelated to using Compose as a third-party developer, and it's more just me sort of streaming my day job, working on the Compose compiler. So that might be really interesting to some people and not to others. But it also requires a lot of context to follow along with what I'm doing. And so in the previous stream, I spent a lot of time explaining a lot of the details about the current task that I'm working on, and also just how different parts of the compiler work. So instead of spending a bunch of time each time building up this context, thankfully we have the streams recorded, and so I'm gonna paste this link in here in the chat so you can go and look at this video. I've pasted some time codes for what this sort of section of the stream where I actually talk about everything that we're doing and why and all of that. So if you want to gain that context, that would be a good place to start, and then hopefully everyone else can just follow along here in the stream. Okay, so the last time, and let me know if audio and everything is good. I think it looks good. Another day, another Compose stream. Yep. All right, so I've got IntelliJ open. Great, thank you. Do I find that streaming your work impacts heavily on your productivity? So far, yes. I've definitely spent a lot of time making the stream like work how I want it to, and that's just been difficult. But I think we're kind of finally getting into the groove of things. I felt like Wednesday's stream I was very productive, and at the same time it was a lot of fun, and I think people got some stuff out of it. But it was nice because I think it was the first stream where I kind of just pressed go live and just went, and so that's how I want it to be, and I think it'll get better over time. But even if I'm not as productive as I would be normally, if I was not streaming doing the same work, I think I'll always be more productive that way. But I think this is providing a lot of value to people outside of my work. Did you figure out how to display IDE pop-ups? I haven't yet. So here's the thing. I'm using OBS window capture to capture specific windows on my desktop, and I don't want to stop doing that. I think that's pretty important for a couple of reasons. One is that I have a single monitor. But another reason is just because this is my work machine, and there's possibility for confidential information or something to be somewhere on my desktop, and so I don't want to make that any more difficult for me than it needs to be. So for now, I'm being very specific about which windows I capture and what it captures. If anyone can think of a way that I can improve the autocomplete experience, let me know. But it is difficult given those constraints. Yeah, I hope it improves over time. Thanks for the good wishes. I'm glad that you're liking them so far. Is there a repo just for Compose so that we don't pull all of the Jetpack repo with it? Right now, no. So right now there's essentially a Jetpack repo, and Compose is part of it. Yeah, sorry. Okay. So here we are. This is the I haven't done much work since we were last streaming, but I did get so all of these tests are now passing. The way that they're passing is, I mean, I just sort of updated them. So you can see here that these constants went from being 2 bits per slot to 3, which is what we're wanting. And you can see some other changes here. And again, so if you're just tuning in for the first time, these, binary numbers here won't make a ton of sense, and that's normal. But if you're curious about like why they take that shape and what this is doing, the timecode video link in the chat should be helpful to you. So there's actually, since we've last streamed, I've kind of changed my mind a little bit about how some of this should be implemented. What we did before, let me pull it up. So before we built this class stability transformer, which is part of the IR lowering. So this is an IR to IR transform, which most of the Compose compiler works that way. And we kind of started building in some like really, poor, quick versions of what the stable inference would be, and you can see how here we sort of started to do that by checking to see if there was a variable field, like a field on a class that you could set. And if there was, then we would mark that class as non-stable, just as like a starting point to have one or the other. And I think this is actually maybe not the right approach. I think we're still gonna have some transform like this where we indicate the stability of it, and then we add some like stable field on it, a synthetic stable field. But I don't think the analysis of whether or not it should be stable or not should be done in the back end. I think that we should probably move this to the front end of the compiler, for a couple of reasons. One, we have a bit more information on the front end, but it's also kind of canonically where that type of analysis should be done. And if we do it in the front end, what can happen is that we can have that run in the IDE and then expose some of that information to the user in the IDE or something if we wanted to. Oh, the music's a bit loud. Yeah, I think I had it louder than it was last time. I just adjusted it a little bit. Let me know. It's kind of a quiet point in the music, so it's hard to know if that was the right adjustment, but I'll try and write some good settings down. also is like this biggest piece of code font-wise I've ever seen. Interesting. Yeah, turns out people like the font. It's Dank Mono. Yeah, the music making you anxious. How is that? You just created an account to say that music was loud. Alright, that was a good warning for next time. Trying to... So it was hovering around minus 37 dB just then, which I think is pretty quiet. It's hard because what I hear in my headphones is not the same as what you all hear. Let me know if that's better. Sorry about that. Actually, I think I'm playing a different playlist. So let me go back to my playlist, which I think is a little bit more chill. Yeah. Okay. So I think what we might end up doing today is trying to build the front end portion of this transformer, which is where all of the actual analysis is going to take place to figure out whether or not the class is stable. We actually have a there's this class here, the composable call checker, and one of the reasons I'm bringing it up is because so this is another place where we do some analysis on the front end, and I want to try and remind myself of what it was doing, and if, yeah, so here here we're saving some information in the binding context, and I want to try and remember if we're using that in the backend or not, because one of the things I'm worried about is we need to essentially do this analysis on the front end and then read that information on the back end, and I think that might be somewhat of a no-no. I'm trying to figure out if we do that in a reasonable fashion. So for instance, here we record that it allows composable calls. Yeah, and then we use that in the back end like this. So here we have we basically have a lambda in IR, which is an IR function expression, and then we're grabbing the descriptor and checking to see if it allows composable calls. So this is kind of part of what I'm worried about, because my current understanding is that JetBrains is trying to move away from the descriptor being present in the backend. So that worries me a little bit. Yeah, see here we're using binding context, which is deprecated. Front-end API shouldn't be accessed, and part of why they're doing this is because they want the new backend. So the new backend, which is the IR backend that we're working in, they kind of want that to be uncoupled from the front end, because when they're done, now that they're done with the back end, they're actually going and refactoring all of the front end. And that's obviously going to be a lot more difficult if the back end is super coupled to how the front end works. Let's see. Dev Souza says, "Hi Lewin, what do you think about the current stage of Compose to use in a new project? I really don't care about changing the code when Compose gets changes. I want to know more about stability. Do you think that Compose is currently in a good place from a stability standpoint? I'm using Compose from basically day one, but I want to start using it in my job. I have the freedom to use it, so company adoption is not a no-go here." Yeah, I mean, this is a difficult question to answer. I mean, so one, you're using the word stability here, and I think stability is normally referred to with the thing that I think you're trying to use is the opposite here, which is if it's going to change over time. And so, I mean, the stability, I guess, can be used to refer to a couple different things, but if we're talking about API stability, that is typically what the alpha moniker is sort of used to represent, is that there's not any API stability. And that is certainly true of Compose right now. We're in alpha. That means that we can change APIs, and we certainly are. Now, I mean, I think what you're getting at is like how robust is Compose? How mature is it to be able to use it in a production setting? And I mean, that's a much harder thing to define. Like what we sort of wanted alpha to mean for us internally, in addition to it still indicating that we could change APIs, because we had all of the dev previews. What we our sort of like our test for being alpha was, can we build something real with this? That's obviously a super subjective thing, and so there's not like a we tried to make it more objective by having a couple of primary use cases that we wanted to cover and things like that, and making sure that we could do that. But you're still gonna find, I mean, it's not a controversial statement to say that Compose isn't mature. Not only is it an alpha, it's never not been an alpha. It's just gotten there, and we're essentially competing with, you know, with a UI toolkit that's had like 12 plus years to mature. And so there are certain things like, you know, we've done a lot of work on accessibility, and some of the accessibility requirements that we have, but we still don't have all of those bases covered. There's still going to be issues. Like I was using Compose the other day, and you know, I noticed some kind of rough behavior with the way text selection was working inside of a scrolling container and stuff like that. So there's going to be a lot of rough edges, and I don't think that you can realistically use Compose today without expecting those rough edges. So it's not just about API changes. I think there's, if like, for instance, if you had stakeholders in the project, you know, that said, hey, we have to ship this thing by this date, I would be wary of using Compose in that context, because there's just risk of you doing something and it like all going great until this one moment, and then there's like something wrong, and at that point, even though everything else went well, that one thing is like a ship blocker, and there may not, for that one thing, depending on what it is, be an easy way for you to fix it. You might be then waiting on us to fix that bug, and that's a spot that you don't want to be in. So, I mean, it really just depends on your situation. What sort of risk are you and your stakeholders willing to take as far as like, you know, shipping timelines and things like that. So I don't know, take that for what it is. Like I don't think there's a definitive yes or no answer here. To understand the Compose internals, where do I start once I've pulled the code base? Well, so you might want to. I guess it depends if you're talking about the Compose compiler internals or the like Compose runtime. I mean, there's if you're just asking like which folder in the repository it is, there's a Compose subfolder. In the repo, actually, it'll be platform framework support Compose, and that's where all that code is. But to dive into internals, I mean, there's all kinds of stuff there, so it might depend on where you want to start. For the compiler, what I would recommend, starting on this file. Let me pull it up. So there's a file called Compose IR generation extension. And this is sort of like the primary entry point for the compiler. So this implements IR generation extension, which is that's a JetBrains thing. So this is one of the Kotlin extension point interfaces. And here we transform a module, an IR module that's passed in. And like basically everything down here, this is like, these are all the different pieces of the Compose transform. And that would be a good place to start. And some of it is reasonably well documented, some of it's not. But that would be where to start. All right. So yeah, I'm a little bit worried about using this binding context to pass information through. We're already doing that in some places, but I'm not sure I want to add to that list. So I think what I'm gonna do, I'm gonna like skip this decision for now. I'm gonna defer the decision until later. I'm gonna talk to some people and maybe see what they think the right thing. The font I'm using is called Dank Mono. I linked to it in the previous screen, but if you just search for Dank Mono, find it. Okay. Yeah, so let's leave this how it is, I guess. And instead, what I'm gonna try and do is I want to try and if you remember from last time, like what we end up doing here is like, so maybe foo is one of the classes here, and basically we pass in foo.stable here as the argument, as the changed argument function, because of foo here. So one of the challenging things for us is going to be actually referencing this property and figuring out the right way to store that symbol and stuff like that. Let's go ahead and try that. Let's build a test case first. And got tests. Oh, actually, we want to. In these tests, we're gonna start using the entire Compose transform pipeline here instead of just the transformer. So let's see, do that. I did in this class. Fast. Where's this override that? Oh, I guess it's the default override. Yeah. Right, okay. So by default, this class just runs the whole transform. Whereas in our test, we were limiting it to just the class stability transform. So what I might do is first add this to the main transform that we're doing. And then just use the default. So I'm gonna put it as the first thing that runs. You were able to sleep. You were about to sleep and then got a notification. Guru 308, where do you live? What time is it there? Singapore. Oh man, far away. Well, I don't know. I don't know how I feel about you skipping out sleep to listen to me. I feel like maybe you need some sleep. All of it's recorded. You'll get it again sometime. Interesting. My keyboard. Not. Oh no. My keyboard is like acting up right now. Ooh. Happening. I'm gonna unplug and you always watch the recordings. Oh my gosh, it's almost 2 a.m. Not good. Gonna be pretty early in the morning by the time I'm done. I think maybe recording makes sense. Okay, so all of that good. So now that we've got this here in our main transform, like the IR generation extension. Now this test is going to use it and all of the other Compose transforms. How do you manage dependencies in the Compose code base? We use Gradle. I mean, I'm not sure if that answers your question, but it's the Gradle project. So I feel like I have too many windows open. I'm gonna around. Okay. I mean class dependency. Oh. Sorry, I'm not sure I understand your question, but you're asking like in a Compose code base, how do you like, so if you're using Compose in an app, how do you manage dependencies? You might be asking like if you want to use some sort of a service locator or dependency injection framework or anything. If you mean that, then it shouldn't be much different than how you would in a normal Android project. Do I get disturbed by the chats? Can't code if I'm constantly being interrupted. Yeah, I mean it is distracting, I guess, but I think it's part of the point of the stream is to interact with you all. So I don't mind it. I think it's kind of neat. You know, sometimes I'll maybe ignore the chat for a minute or two and then come back. The source of Compose. You don't have to apologize. Fine, the chat's there for a reason. I can choose to ignore it if I want to. So yeah, I'm not entirely sure what the question is, but inside the Compose project, we it's a pretty standard great old Java project. I mean, we do some custom stuff for some of our build infra, but not much. Okay, so let's see. Let's just see if these tests pass. Oh, and I think I need to change this to compose IR transform tests. All right, yeah. See how that works. I'm surprised how many people love this font. I think that's really cool. Definitely go check it out if you like it. So the maintainer of this font, Phil Fluckdoon, he just sort of announced the other day that he's gonna stop maintaining this font. I think sales kind of declined and it was taking up a lot of his time. But I mean, I'm sure he would really appreciate it if you went and supported him. I think there's a big discount on the font now that it's like the final version of it. So check it out. What is this? I think that was from this build. Thank you, Merle. Or Mert. I have a question regarding navigation with Compose. Will it be bundled to Jetpack navigation or with Compose? Kind of neither, I think. I think it'll be an extension module to the navigation architecture component. That's my current understanding. How to do scroll state and lazy column, or get to know the last items reached for pagination. Yeah, this is basically like lazy columns current implementation, your current API rather is kind of underpowered. There are some things that are impossible to do right now. Like you can't hoist the scroll state up out of the composable, but at some point you'll be able to. It's sort of an API that's still being iterated on. So this is just sort of, unfortunately right now you can't do everything with lazy column that you should be able to do. How the font looks on the website. Yeah, that's a good point. I'm not sure. I think, yeah, if you click through this, it'll show the font on different ligatures and stuff. So it's there. Yeah, Guru can go to sleep now. Good night, Guru. Lazy column 4, not as smooth as scrollable column. Yeah, I mean that's an interesting thing. I mean, for one, like if you have, at least in its current implementation, if you have like just 10 items or something, you might be better off just with scrollable column. If you've got 1 million items or an infinite amount or something like that, then lazy column's always going to be better. So the thing is, we're actively working on some things right now that are going to make lazy column a lot more efficient. It's sort of initial implementation was like a proof of concept around using like what we call subcomposition and stuff like that. But the way that proof of concept worked had a lot of extra overhead that isn't actually needed, but because of the APIs that were available in the runtime and stuff, that was like a necessary middle step. And so lazy column should get faster and faster over time. Could you repeat what you do? I just joined. Yeah, so my name's Leland Richardson. I'm a software engineer at Google. I work on Jetpack Compose, which is like a new UI toolkit for Android, and I'm one of the engineers that works on the compiler and runtime of Jetpack Compose. And so right now we're working on the compiler, and I'm showing. Basically, I'm doing my day job live. Did anyone ever tell you you look like Jake Gyllenhaal? I've gotten that a few times. Yeah. Actually, so funny story. One time I was in Amsterdam for a conference, and I was there with some friends at the conference, and we were like in a bar, just hanging out one night. And so there's, like 5 or 6 of us or something, and my friends were trying to get a picture with me, just cause like we all knew each other and we were friends. But someone in the bar saw that and thought that they were like getting a picture with a celebrity. I think maybe they thought I was Jake Gyllenhaal, I'm not sure. But so then these like random people just came up to me and were like, can we get a picture with you? And I tried to convince them that I was not Jake Gyllenhaal, but all of my friends decided that it would be better to tell them that I was lying and that I was. So is there some documentation tutorial to get started on the Kotlin compiler? So far I've only found the code. Yeah, the documentation for working on the compiler itself is pretty thin. There's not a lot of resources, at least not that I'm aware of. So sorry about that. Compiler streams make me productive. I like it. Good. I'm I'm increasing the productivity of others by, I don't know how that works, but sounds great. Okay, so the test came back, test passed. So this basically worked. What we want to do is add another test case, and this one we want to include some composable functions in it. Right. So basically, the idea here is that we should be able to do something like this. So let's say B is a composable function that accepts any, and any isn't a stable type, but it can have stable subtypes. And so foo in this like small code snippet is stable. And so if we pass a new foo into B, we should expect some. What we want to do is we want to generate a constant that we pass in to the synthetic change parameter of B that goes ahead and grabs like foo.stable. So this will be like an interesting starting test case here. Using two inner layouts isn't good practice because it draws the UI 2x. Is there anything like this in Compose? I'm not sure I understand the question. There's basically like conventional wisdom in Android is that you don't want very nested view hierarchies for various reasons, but in Compose the cost of highly nested view hierarchies should not be as high. So that wisdom, if that's sort of what you're asking about, that wouldn't necessarily map over. I mean, granted, doing more work is always going to be more expensive than doing less work. And so that isn't to say if you can avoid the nesting that you shouldn't. It's just not as much of a thing to worry about in Compose. Can Compose be used for building home screen widgets in Android? That's a good question. Someone just asked me this. So it could be used. It's not currently. But I mean, so I don't know what like the widgets team or whatever is like doing or what their plans are. But I do know that there are a number of teams at Google that are interested in using Compose for various things in the future, and so this could be one of them, but I'm not sure. I used to watch John Blow work on his high language, but C++ gave me heebie-jeebies. Kotlin is readable at least. Yeah. What does stable mean? Google ignores these operators in search. Yeah. So even if you Google searched it, like not a lot would show up. So if you scroll to the top of the chat, I put a link to the previous stream, and I explain a lot about this, and also if you want to go to there should be stable. What is it? Yeah, should show up. Oh, interesting. I wonder if it's not stable.kt. Why isn't this showing up? Close run. I'm not sure why that didn't show up in the search, but if you went here, this could explain it a little bit better. I mean, nested layouts such as constraint layout. Constraint layout, it's expensive for drawing the UI. Can I use nested layout in Compose? Basically, yes, you can use nested layouts in Compose. Will Compose kill fragments? They're definitely still going to exist, you know, in the platform, but you know, long term, the need for fragments and their life cycles and the patterns with which we use fragments might change pretty dramatically, and you know, some people may choose not to use them. How does the behavior of Compose look when we want to handle different Compose views depending on the screen width, supporting for tablet? This looks similar to config changes. Yeah, so I talked about this in a previous stream, I think, but like, you know, basically you can imagine that we would just have something like current configuration dot orientation. Like, basically, you can imagine that the current orientation, the current configuration would just be some state objects, just like any other piece of state. And you can use logic, you can use that value and conditionally render, or use that to conditionally create values and use that. There's all kinds of things you can do here, but the idea would be that if this value ever changed, this composable would just recompose, and so then all of the composables in your hierarchy that depended on orientation would recompose every time the orientation changed. And so if you're able to, I think Compose will work much better with not restarting the activity on configuration changes. So if you're like starting a greenfield Compose app, that would be my recommendation. Is Compose 100% Kotlin from the compiler perspective as well? I think so. I think there might be like one Java file or something for like errors, but even then I think we just refactor that, so it's basically all Kotlin. Will Compose also be used to do iOS UI? It seems like that it can be used for also doing multi-platform. With Kotlin multi-platform, we can write both UI and business logic with Kotlin. Yeah, I mean, I think this would be really cool. This isn't something that like Google is working on, but you know, for instance, in the project, you can find a lot of like desktop stuff, which is some stuff that JetBrains is working on, and that's where all the multi-platformness comes in here. And I mean, that's easier to do because it uses JVM. If you wanted to work with iOS, it would be more difficult because our compiler plugin right now doesn't support Kotlin native. And so, you know, you'd have to figure that out. But I mean, long term, I think it's a pretty interesting thing that could happen. One thing that hasn't settled with me yet is recomposition versus conventional tree mutation. Isn't mutating one node easier compared to re-emitting the entire subtree? Yeah, I mean, so that's a great question. Like, if you were building and maintaining a tree, and you know, you knew you just needed to update one node, and then it was like, that was all you needed to do. Writing the code to just update that node would almost certainly be faster than any approach that we're talking about here. So the Compose runtime and all of this, it does consume overhead. It takes some work, but the real value comes in from the programming model. And so the ability to write a function that just says, given the state, here's the UI we want, that's the important bit. And so being able to write code like that is really nice. And so what the runtime is trying to do is trying to make it so that when you write code like that, we can efficiently update the tree. And that's the difficult part. Why is compose content added inside selection container in the set content function that makes whole compose content selectable? Yeah, I mean, I always found it weird that text on mobile platforms wasn't selectable by default. I think in terms of accessibility, I think it's really frustrating that it's not. I think the number of times that I've wanted to, like, you know, select some string somewhere in a UI and then like paste it in a text message or in an email or something on my phone, but having not been able to because it just wasn't selectable is like very frustrating to me. It's one of the things I think the web really got right. I think we ended up going down that path for Compose, but I'm not sure. I mean, it's in a selection container because the selection subsystem sort of needs that container present at all times, and you can, you know, switch things off and stuff like that. But that's probably the extent of my knowledge there. I guess the folks from Kotlin libui have done a port of Kotlin native. Does not know how he completes to port and if he dropped the project. Yeah, I don't know much about that. I'll check it out later. Google's Compose sample apps don't work with performance because it's alpha. They're working with low FPS. Depends which sample app you're talking about and what the case is. It's definitely something we're cognizant of, but yeah, I mean, there are a lot of improvements to be made still. If you have something in particular that's slow, let me know what it is, and I could try looking into it. Okay. Back to coding. Oh man, my keyboard is having trouble. Scares me. So this test, see what it generates right now. But this is what we need to work on. Resolved reference. Oh, okay. So yeah, we need to import. Can't type today. All right. It should make that happy. So if we look at this file, there's gonna be is it frozen? Oh. There's gonna be some function that like builds that changed expression. Here. Okay, so this is what I'm looking for. Build changed params for call. This is what we're gonna work in. Moment. Especially Jetcaster. Yeah, I mean, so Jetcaster is trying to do a lot of interesting things, and I think, you know, sort of pushing the limits in a few ways, and it's actually led us to look at a few APIs to try and make them more sane. I don't know. Is there any way to disable selection? Yes. I forget what it is off the top of my head, but there is a way to disable selection. Books that I recommend about software development in general. Honestly, I don't have a ton of books to recommend. I've definitely read some books, and there are some books that I've tried to like I have the you know, I've got the Newth art, what is it, Art of Programming or whatever. You know, I've got those books, and I made my way through one, but I just never got super into them. I don't know, if books are like the format that you really enjoy to learn stuff, I think that they can be great, but it's not how I find myself learning this particular sort of field. So I don't have great recommendations there. Okay, so what this does, this function takes in, we've got this param meta class, which has some fields here that get set somewhere else, about the nature of the parameter. And this is probably what we want to augment. So we probably want to add some, I don't know if it'll be a Boolean, like if it's stable. There's kind of like there's a few states here that that a parameter could be in, right? So let's try and enumerate them, I guess. So a parameter, it could be guaranteed to be stable, or it's known to be stable. And then there's the inverse, where it's known, or it's guaranteed to not be stable. And then there's this middle ground where it might be stable, and then we need to generate some runtime expression for it. And basically these are pretty easy cases. Oh, arrow key. And then it's that third case where we're going to generate some expression. And actually, in the test that we have here, so in this test, foo is being defined the same compilation unit as this call site. So that means that whatever we've set the stable flag to on this class, it's not going to change. Or like we basically we know it for sure. We don't have to generate any expression because it'll always be the same in that compilation unit. So we're actually in one of these two cases to start off. So let's go ahead and let's try and solve those two cases first, I guess. Why is the preview annotation, why isn't it default for set content? I'm not sure what that question means exactly. Oh, I guess you're saying like if I put something in set content, why don't we just render that in the preview? Which is a pretty good question, actually. And we totally could if, yeah. I don't know. I think that's a pretty good idea to try and do something like that by default. So I'll maybe mention that to some folks. Yeah. Okay. So I wonder if we should have some sort of a class to represent these states, and then we could just have like stability. Oh, there's so another thing to consider is like what this class has is it has this mask slot and mask parameter, and if these are set, what that means is that like we're passing in a parameter directly. And so actually that might be a good use case to target first, because that actually might already work. So if we did as a test, let's change this test a little bit. Let's say A took in a foo. It doesn't even need to be a foo. It can be any. So let's just say that we just pass on X here. This is an interesting case. I mean, basically what we want to make sure is that we continue, we basically pass that metadata from X. Whatever metadata was passed into A, we want to continue it on, we want to propagate it onto B. And we wouldn't do this before because it wasn't stable, because it was any. But now it could be, so we need to essentially always do that. That's a good, it's an easier first case for us to handle, so let's do that. Maybe preview can decrease Android Studio startup performance. I mean, it could, but I don't know if set content would, I mean, like basically taking the set content as one of the possible previews for Android Studio seems reasonable, and that wouldn't that wouldn't affect startup time. Adding preview to set content might not work if the composable functions have parameters. Yeah, okay, so that's true. So set content, if the lambda that you pass to set content, if it captured something from the outer scope, then we wouldn't be able to use that for preview. But if it had no closure, then we probably could, and so maybe we'd be able to figure that out. But yeah, that's a better answer to why we're not doing it right now, I guess. It might be just because we can't do it in all situations. If it has a capture scope, then we're stuck. Okay, so this is the code that is generated from this. So in this case, you can see here that we're doing something wrong. Well, we're doing a few things wrong, actually. One is that we're not generating any code to check the any or this x, like, because if x was stable, then we would want to generate code to check it, which is going to then result in like a dirty flag. And then another thing that we're doing wrong here is that we're only propagating two bits here, and it should be 3, and so that's a place that we missed to update that bit mask. Will Compose next year be the standard way to create UI in Android? Kind of hard to define what the standard way to create UI in Android is. I mean, views aren't going anywhere, like they're baked into the platform. But you know, Jetpack Compose is the intended next generation like UI toolkit. So it is like the successor of views in a way. But also, I mean, that there's a big maturity question here. So we need to sort of get to 1.0, which we said will happen, you know, next year. But like, anyway, there's a lot of factors to consider, and I think that it's important to understand that there's gonna be a pretty long period where both views and compose will exist in harmony. That's fine. Okay, so let's fix a couple things here. So one, this should be a 1. We should find out where that is. So it's basically we're gonna be wherever this is used. Changed or inferred change. Isolate bits at slot. So we need to do that. I wonder if this implementation is wrong. Bits for slot. Okay. So I made this all bits thing. That should work. Here we go. Okay, so this is basically wrong. I wonder if we should arrow shift bits for slot. Like, I wonder if this should actually be like one of these isolate bits at slot thing. This is anding it. So the mask bits. What is so this shifts the bits in that mask. So I mean, basically if I change this, then I assume that this will update. But I'm not sure I understand code path. I guess I might want to see what happens when we shift the argument. Do that. I think this should be, we should at least do this. So param state all bits dot bits for slot. That's semantically more correct for what we want. Please upload the code on GitHub. Yeah, at the end of this stream, I'll push this CL so that it won't be on GitHub, but it'll be in AOSP. Hello, Wisdom. Wakocha? Not sure I'm pronouncing that right. Okay, so that I mean fixed that to some degree. And I want to see what we do when we have like so the index of the parameter is changing now. So we're going from index 1 to index 0. And so that means that there's going to have to be a shift in this expression. And I want to see if we're doing the right thing in that case. I think we're probably not. If it's certain. Oh, actually, well, okay, so it's only this code path where so this does the shifting. So let's just see what happens. I could someday make a video of how to contribute to Compose or AOSP in general. Yeah, I could. There's a Medium article that was recently written about this. So Jetpack AOSP. Let's see what. I don't think this is the article I'm thinking of. But there was a good Medium article that was just written that talks about this, but I'll try and find it and then maybe link to it next stream or something. Detailed here. I think this is it. Oh, well, let's see. Okay, I thought there was a Medium article, but there are some good details here for how to contribute. And if you want to and you're trying to and you have any trouble, then feel free. Yeah, the one by Andrea. Yeah, is this it? Yeah, this is what I'm thinking of. Okay, so thank you, Danny. That's what I was thinking of. But also here's that README in case people were wanting to see that. And if you do end up having any trouble, you know, feel free to reach out to me on Twitter or something like that. Be happy to help. Okay. About the Android X GitHub, I tried to run the desktop demo from Compose and I could not make it work. I could make it work with the Android repo tool only. Yeah, so right now, I mean, so the Android X being moved to GitHub is really exciting, but it's important to understand like what's happening there. So right now, all of the Jetpack libraries, like all of Android X, is it's in one repo, and we essentially moved to that repo, or like we made GitHub one of the remotes of that repo, and so that's great. So all of the code is on GitHub, but that doesn't mean that like every single project in that repo is ready to accept contributions from GitHub, but some of them are. And so some of the, I think it's like paging and work manager at the moment. But for those projects, you can submit PRs on GitHub, and what'll happen is like those PRs will get like synced with our internal tooling and Room 2. Yeah, thank you. And so a bunch of cool stuff will happen where like all of the build infrastructure that we've worked on over the years for this repo will continue to work, and we'll run all of these internal tests and stuff like that. And then we're able to then take results from that and give that feedback back to the PR author and all of this stuff. But all of that syncing, it's kind of complicated, right? Like it takes a lot of work, and not all of the projects in the repository are like set up in a way where they can do that. And Compose is one of those projects. It's not set up in a way where that can be facilitated. And there's a number of reasons for that, but like basically the build setup for Compose is significantly more complicated than for other projects, in part because of the compiler plugin. And so eventually, like I'm hoping that we will be able to accept contributions through GitHub, but we're gonna have to make our build setup a little bit more stable and simple before that happens. So it's definitely something I want. I know a lot of other people want it too, but you know, this like GitHub tooling that we're working on is sort of not ready for Compose as a customer. And so we're gonna have to wait for that. Okay, let's see what this test came back. Interesting. That did not change it how I thought it would. But what is happening? This didn't work. See. Oh, because I didn't change the I changed this, but not this, which this is like the source, and so that's the important thing. So now I want to run it. See what happens there. Okay, so this is where we hold all those up. I'm pretty confident that this will work like we expect now. Yeah. Okay, so let's see what this ends up doing. We'll see that this test results in this. And so now what happens is oops. Oh, that. So we take the changed bit mask and then we shift it 3 bits to the right, which is correct. So right now the metadata for X is stored in the second param slot. And we need to shift it to the first param slot, which is where B expects it. And so, so we shift it right by 3. And then we AND it with this, which makes sense, and that all works. Okay. So yeah, I'm pretty confident that we've converted this logic over correctly. So the next thing that we want to do is like this function, because of this any here, it's falling down a code path where it assumes that it'll never be able to skip this composable function because one of the parameters is unstable. And so we need to change that. Basically, we're now generating code in cases where it's possible that X is a stable type, because any has some subtypes that are stable. And so basically it's falling into let's see, where did I just write that stuff? Yeah. Nope. Where's param meta? So basically it's falling into this case, right? Where it might be stable, because some subtype might be. And so we need to handle that. And where I do that is here. So basically I have some code that does some things conditionally, where if I can skip the execution and I calculate that based on stable mask, which I get by looking at the types of the params. And so that's what needs to is it JUnit 5? Honestly, I have no idea. I think so. I think, well, it's some JUnit, but I don't know. Where is this JUnit coming from? Here we go. It's JUnit 4, apparently. Okay. So basically this is kind of the problem here, is that we're calculating stable based on the type, and we kind of want to change that. So This is inside visit composable lambda. Since our test isn't doing that, I'm gonna change visit restartable composable function, which is the path that we're going down. And so we get all the parameters. And so we're doing something similar here. So we're going to change this logic, because now it's not like right now, if one of the parameter types is not stable, then we say, oh, okay, this function cannot. But instead, what we want it to be is if this basically we want to know if any parameter is guaranteed to never be stable, which is a slightly different question. So we can go ahead and change that. Just what? One of the things that I just thought about is kind of the original question that we had at the beginning of the stream, which was, when we do this stable analysis, can we do it on the front end? And if we do it on the front end, how do we pass that information to the back end? And I want to avoid using descriptors, because the Kotlin IR is trying to move away from using descriptors in the back end. They're currently deprecated, and we're using them a lot, which is not great, but I don't want to add more cases. But one thing, and this is, so I was talking to Jim Sprock about this yesterday, and I think this is what he was trying to tell me, and I was just too dense to understand what he was saying. But I think that, so I think it might be reasonable for us in the backend to still grab the Kotlin type of something, or even if it's not reasonable, the IR type will be available. And I think what we could do is, in the front end, we could annotate the type of a given expression to be the same type, but just with an annotation on it. And if we did that, then I think it would show up in the IR type, which would be a place for us to check it. So maybe that's the strategy that we'll go with, but I'm not going to mess with that today, because we're already kind of going down this other path. But I think that might be the right way to approach it. So that's interesting. So we're probably going to want to move this function right now. This like is stable function. It's just an extension function in our abstract compose lowering. Hi K-Swiss, thanks for tuning in. This is like, the logic here is going to get more complicated as we build out this feature, and so I think we should probably move this into a more isolated sort of standalone location where we can maybe test it independently. What is lowering? So lowering is a term that we refer to, like, so I mentioned that the Kotlin compiler has we're working in the backend currently, and the backend has what we're referring to as IR, which stands for intermediate representation. And so if you think about it, you take the source code, right? Like the code that you write, and the Kotlin front end, you know, parses and analyzes that content and basically builds up a tree that we call an intermediate representation that that sort of has a lot of that analysis in it. So it's like strictly more information than the source code has. But that's still relatively high level concepts. You still have like higher level notions in that representation. And so like for instance, like a suspend function or something is like a pretty high level thing, and so is a lambda and a default parameter, and like all these things are higher level Kotlin language concepts that aren't directly represented in, for instance, JVM bytecode. And so what happens is that tree, we have several transforms that run on it, which we call lowerings, which will take these higher level concepts and sort of replace them with equivalent but simpler lower level concepts. So you look at like so this is file class lowering. This is in the Kotlin compiler itself. So you can see that the package here is backend JVM lower. Inside of here, so inside of this namespace, you'll find a bunch of different lowerings, but like this is one for Kotlin that essentially turns like the top level declarations into a file class. So like if you have a top level property, that's not representable in JVM bytecode. So we lower that IR of the file to be an IR of a class where that class then has the top level properties and stuff like that. And so that's just collectively what we refer to as a lowering. So hope that makes sense. But so okay, so to start, I'm just gonna say like what we want is we want to know if a given type is okay. Let's imagine that we have I'm gonna get rid of this because this was, we didn't really use this, I don't think. I'm gonna rename, instead of getting rid of it right now, I'm just gonna rename it. Keyboard, really being weird today. So this is not the name I'm gonna keep, but ability bits. No, I don't. Then in here, I'm gonna make a new enum now. And then here I'm gonna enumerate the like possible states here. We've got like the one case is where for a given type, and here maybe we'll call it type stability or something. We might know that it's stable. So guaranteed And then there's, I think I'm gonna, so there'll be stable, unstable, and unknown. So basically, it'll be this if we know for sure that this and all subtypes will be stable, and it'll be this if we know that this and all subtypes are guaranteed to be unstable. So an example here is like if we, if there was a final class with a mutable variable in it, then we would know, okay, well that's unstable, and there's no subtype that's going to be stable. So, so we can generate code. We can not generate code in that case because we know it'll never be true. And then unknown, which is the case that we're trying to improve, which is where, like, let's say in our test where it's any. In this case, we're gonna generate code that might like do some work if the type is stable, because it might be stable and it might not. So now what we can do is we can say, let's just say get stability. And then this will return type stability. Then I don't know if the type is null. Basically, unknown is the safer case, I guess. Like if it's unknown, then we'll generate code that deals with both. If it's unstable, that code would always be correct. Like it would always work, but it might be less efficient. We might miss out on some optimization cases. So I'm gonna create a new one of these, which stores this stability thing here. Type stability. Naming is not my strong suit. So I think I'm gonna move this out then, so it's not a nested class. I almost wonder, I think maybe this should be an analysis. Ability.kt. I think in this class I might add some more things later. Okay, we'll go ahead and import it. I'm not sure how much this is going to be relevant anymore, but we can go ahead and we can let's just give it a shot. Got here. So you might want to take the is stable, or changes to ability, and I guess we can default to unknown. Let's just take some of these cases. So when the type is an error. This is kind of a weird case because at this point this is just this is going to be a compile error regardless of what we do. So I think here let's just generate unstable. So if it's a type parameter, this is an interesting case. So in this case, we wanna do unknown, because if it's a type parameter, that means that it can the stability, like it's sort of similar to being any, right? So it means that there could be some subtype that implements it. Now, what we should probably do is we should look at the upper bounds of this type, and if the upper bound is is unstable, then the type parameter itself would be unstable. Okay, and so then is special type. I don't actually remember what that did, what that was. This is kind of similar to it being error, I think. I think. Weird. I'm not sure what the right unit expected type or no expected type. I think I'm just gonna be conservative here and just like do unstable in some of these cases where I'm not sure what the right thing is, but we can deal with some of that later. Gosh, Lord. All right. So if it's a primitive type, then it's going to be function type, then it's also and enums are something you always consider stable. Strings are not technically primitive types. They're also strings in JVM. So then we fall back to say, okay, like is it marked stable, like a stable annotation? In that case, so if it's nullable, then the stability is just if the non-nullable type itself is stable. So that's how we calculate that. So in this case, then if it's nullable, we're gonna oh my gosh, keyboard, you know, a long time ago I got this Microsoft ergonomic keyboard. This Bluetooth one. I used to have the wired one, like the ergonomic 4000 or whatever it is. And so the first one I bought of these, I hate it. I like the form factor of it, but the first one I got had like terrible Bluetooth lag, and so I just like threw it away. I like got rid of it, and I stuck with like my wired keyboard for a long time after that. I recently bought another one of these, and it's been working great until yesterday. And now all of a sudden I'm getting all of this keyboard lag, and I don't know why. It's frustrating. Yeah, I may have to switch back to the wired keyboard. I mean, it's incredibly frustrating if the keys you type don't show up. So if it's an inline class, then we just get the stability of the underlying type. All right, and those are all those cases. And so if it didn't fall into any of these, then we're just gonna fall back to unknown. There's actually there's another case here though that we want to deal with. So like when final and concrete and final and unstable, and when it's concrete and final, then we should be able to I don't know. I need to think about it. There's more cases here. Have the stability. So we need to change the type of this. So instead of a Boolean, type stability. Oh crap, sorry, I forgot to switch over. Thank you. I almost went the whole stream without messing that up. Next time. Sorry about that, everyone. We need to agree some way to tell you. Yeah. Yeah, I mean, you all are really good about telling me in the comments, but when I get in the zone, I tune out the comments for a minute, and so sometimes it goes too long. Sorry about that. What would be a good way? If anyone can think of a good way to signal that to me, let me know. But hopefully I just get better at it over time. I feel like I am getting a little bit better. I didn't... I feel like I did it a lot. Like the first two streams. I feel like the last two have been not so bad. So we'll see. Okay. Yeah, special emoji. Yeah, maybe, I don't know, I'll have to look into it. I know that there's like these like bot commands in Twitch chat and stuff that I do think, so we'll have to come up with a sorry, Asher, I did that thing where I was coding in Android Studio, but the stream was just showing my full screen camera, and it just takes me too long to see the people that are chatting and saying, switch to Android Studio, you idiot. So yeah, a better way to alert me of that. Okay, so I mean there's a lot more that we're gonna end up needing to do here, but this is a decent start. So let's see how that works when we use it in this function. Yeah, Asher, if you could ask if they have any ideas, that'd be great. I do think I'll look into what I can do with bots. First Android engine that transforms water into code. Are you expecting me to drink something other than water? What water's my programming fuel. Water and coffee. My coffee has run dry. Or espresso rather. But, okay, so we get the type. So let's maybe turn this into like a win expression. Ability. Oof, the keyboard is frustrating. Missing a lot of keys. Okay, so see, look at this. I don't know, you're hearing me type and nothing is showing up. This is incredibly frustrating. Okay. Coffee. Well, I don't think I drink an unhealthy amount of coffee, but I definitely drink a lot of coffee. So I have I essentially have a double espresso after every breakfast and lunch my day. Do I need to charge it? So actually, no, I don't think so. That was my first thought. I actually just replaced the batteries with brand new ones. So I don't think that's it. Wonder if it's because you're streaming. I don't know, maybe. It was actually, so it was acting up before the stream. So I'm not sure that that's it. Yeah, do I need a macro? Maybe I need a macro, a chat macro for what font I use. Yeah. I'll need to look into the whole macro thing. I haven't done anything with that yet. So right now this is where do we use this mask? Because right now I turn this into a bit mask of instability Boolean array. Get why I did that. Where do I use that? Okay, so if there are any unstable params, then we fence the whole expression with a check to see if any of the unstable params. Oh, okay. So this is part of what I add to the should execute expression. So really so the unstable mask, this should, we should have the same thing, but it should be guaranteed to be unstable, not unknown. So I should probably just keep it how it is. And the name even still makes sense because this is really just when it's unstable. So if it's unstable, then I would return true here. But I would do this. So if it doesn't have a default value, so here's the deal. Like if a type is unstable and it doesn't, if a parameter has an unstable type, like it's a type that is guaranteed to be unstable, and it doesn't have a default value, then that composable function is never going to be skippable. So we go ahead and set this to false. But if it does have a default value, then we consider not providing a default value as something that doesn't break the skippability of a function. I'm not able to use constraint layout. I'm using Jetpack Compose Alpha 9. So we don't have an Alpha 9 as far as I'm aware. We've got a dev preview version 9, which might be what you're thinking of. So which constraint layout are you using? Because we have a constraint layout composable, and I don't remember exactly which dev release that came out in, but it might be after 9. But if you upgrade to the alpha, then constraint layout should be usable. Okay. Let's see what happens when we actually I want to debug. So what I'm thinking should happen now is, okay. Basically we should see, we should go through these parameters, and int should be stable and any should be unknown, but not unstable. But actually I'm not sure that it'll end up that way, so we should check. Because I think the get stability function isn't smart enough to return the correct thing yet. I'm not sure. But what that'll then do is that'll cause this function to have a lot more machinery generated in the top of this function, and we'll have an if expression around the body, and this will turn to dirty instead of changed, and we'll see some other stuff like that. See how that goes. Can we expect beta near Christmas or before? I can't really comment on any timeline that hasn't already been like officially stated. So the tagline is that we should be able to get to a stable 1.0 sometime next year. So that's probably all you're gonna get out of me as far as that question goes. Okay, so the design document for what you're implementing. Yeah, that's a good question. I'm not gonna share it without some sort of approval, but I could talk to some people and ask about it. I mean, there's nothing in there that's confidential, but at the end of the day, like if I write a document in Google Docs and people comment on it and everything, like they have the expectation that their comments are private and not public, and I don't want to change that or breach any of that confidence. So I don't know. I have no problem with the design document being public, but I'll just need to talk to some people about that kind of thing. So maybe, but I can't do that right now. But if you go to the link at the top of the stream, I mean a lot of what I covered in there is basically what the design doc would be covering. Okay, where are we? So we're looking at so we're going through the params, and so the param we're looking at here is y, which is going to have int, and so that means so we didn't get the subject of the win in the debugger, which is kind of a bummer, but basically it's in the else case, so it should be stable, which is what we expect. And then so this one was probably unknown because it's not stable, because this parameter it should be type any. Yeah. So stable and unknown, which is what we want, and so then both of these will be false, which means can skip execution will be true, which means it'll go through all of these other code paths that it wasn't before, which is important. So test. How do I get to my test here? Run. There we go. Okay. So let's see. Oops. So okay. So a lot of new stuff here, which is what we expected. So let's take a look at this. So y is stable. So we do this whole dance, which is what we want. X might be stable. Yeah. And so we do the whole dance with X. Great. And then we do all this. Excellent. Yeah, so this is all looking good. This is basically what we wanted to happen. And now what would happen here that we don't want, so like if we can generate another 10 test here, test composable call with unstable final class in same module. So let's turn foo into something that's unstable. So if it has this keyboard killing me. So now it has a mutable property, and so it won't be stable. Oh, but you know what? Okay, so now the question is if X was foo, what would happen? I think what would happen right now is basically the same code would get generated. Just this is foo, and that's fine. That's valid code. But the problem is that this is never going to be true, and we know that. So yeah, so this is never going to be true because foo is never going to be stable, and it's a final class. So there are no subtypes of foo which exist that could be stable, and there are no expressions which exist which could be stable and satisfy that type. So because of that, we're wasting resources. Like this code is wasteful then at that point, because we know at compile time that it's never going to be executed. So in order to make that happen correctly, what we need is for this to generate. Let's just go ahead and run it, because I'm not, maybe my code's smarter than I think, but we need the stability of foo to return unstable instead of unknown, which I think is what it'll currently return. Let's see. Leland, seeing you inspires me, and I think most people watching this stream. Can you share with us your background on compilers and how you got to love it? Well, first of all, thank you very much. It's a nice thing to say, and I appreciate it. My background on compilers, I actually talked about this a little bit on a stream a few days ago, but I don't really have much background on compilers. Compose was, I have, most of my background is around UI toolkits, and in particular, I was very involved in the React community, and so I have a lot of background around this sort of programming model, and also like building out UI toolkits like this. I think I essentially got hired on the Compose project because I was working on a side project called Recoil, which was essentially a port of React to Kotlin and Swift, and I was working on that just as like an interesting side project, and I think that basically. Some folks at Google saw that and kind of reached out and wanted to know if I wanted to build a recoil that would sort of have the backing of Google, and be for Android and built into Kotlin and do some cool things with the Kotlin compiler and stuff like that. And so that was. I kind of mentioned this in the other stream, so I won't regurgitate everything, but basically I found it to be a really cool opportunity where I could both leverage expertise that I had with UI toolkits and declarative component-based UI, and also shift and like learn something new, like really challenge myself and get out of my comfort zone. By working on things like the compiler and stuff. And so there are other people on the team that have a lot more experience with compilers, like Chuck Jazdowski, who was hovering in the past few streams. I'm not sure if he's here today, but he's got a lot of experience with compilers and language design, and so he's been a great mentor for me as well. From day one that you joined Google, the compiler was already on the table. So there was basically an effort to try and see what we could do with the Kotlin compiler for declarative, this like declarative paradigm, and that was what I started working on right away. And it wasn't always clear that project was like going to succeed in a big way like it did. That was kind of an exploratory project that ended up doing very well, and is now Compose. Recoil wasn't a compiler thing. It was building just building the library. And okay. Yeah. So basically, what I thought would happen happened. So so this is going to oh, sorry, back to Grid Studio. Yeah, JSX and Kotlin. Yeah, so really early on in this project, as Andre is mentioning, we actually went a lot further in sort of exploiting the Kotlin compiler, and we actually changed the parser quite a bit, and a lot of the front end to support like a new type of syntax, which was very similar to JSX for React. And we ended up deciding not to go that route. And it was actually at the time, it was one of the things that I was really bummed about, because I really liked that syntax. But now looking back on that decision, I think it was definitely the right call. What have I learned from SwiftUI's implementation? I mean, I don't know if I've learned that much from their implementation. Like, I don't know that much about one, and not a lot of people do that don't work on it directly. I know a little bit about how SwiftUI works under the hood and what they're doing, and I think it's the SwiftUI, their approach is much more similar to React, in that they kind of leverage a, you know, what in React you would call like a virtual DOM, like it's an element tree, and they have the same type of thing. Like Compose's runtime and execution model is very different from any other declarative UI toolkit, and that's, I mean, so that's both cool, and you know, some people are worried about some of the decisions we made and stuff like that, but SwiftUI is much closer really to React in design, but they have like a lot of capabilities that are difficult in JavaScript. So they leverage a lot of the metadata in the types that Swift generates in like the actual binary, like C++, and they essentially build a tree that has a lot more information in it than the equivalent tree of React, and so they can more cleverly know when certain subhierarchies of the virtual DOM tree, the element tree, they can be smarter about knowing when one of those subhierarchies is going to be dynamic versus static, and so that's pretty neat. I think that was innovative, and also they similar to us, like they figured out that they kind of needed to tweak the language a bit for ergonomic reasons, and so the way that they do, I forget what they call it, but like the Lambda builder type thing, the way that works, I think is also pretty neat, and it's like a different approach to what we took, but I think that there's an existing proposal for JavaScript to do something similar, so that'll be interesting to see if any of that ever comes to light, which may end up causing JSX to go away, which would be crazy, but like that would be a pretty big win for the JavaScript ecosystem, I think. Waiting Chuck's compound extension Kotlin proposal to move forward looks really cool. Yeah. Yeah, there's a few other proposals that I think we want to make Kotlin, but I don't know. We're not very on top of our game to actually submitting keeps to JetBrains and pushing those forward. But that would be a good one. So I wonder if, let's just add a quick case that would at least get this test to pass, but like seems right. So ultimately here, if so it's final, what do I want here? Okay. I wonder if like what I was gonna say is like if it's final, but maybe what I should do is say if it's upper bound is stable or not. Or what type of, I think I want a simple type. Wonder what so it's grabbing the last kind off of the declaration descriptor. Ugh. Wonder if that's a good idea. Not. Basically what I want to know is if, I mean, one, I guess, like, is just if it's final, but even if it's not, then I could figure out more here. Is it final just proves that it's, can prove that it's stable, but it can't prove. Alright, I'm just gonna, just so we can prove to ourselves that this works. I'm gonna say if, well, that constructor dot declaration. Let me just Kotlin type that is final. Equals constructor dot declaration descriptor dot class kind. What did this do? As class descriptor. I think basically doing something like this. Got modality equals this, I mean, this kind of works, but this probably is not going to be code that we're going to want to keep. But so if it's final, so if it's final and it's not marked stable and it didn't fall into any of these categories, then basically at this point we should be able to say type stability to unstable. So let's go ahead and try that. I think that'll at least get this test to be kind of where we want it. Is this kind of like the rubber ducky debugging method you yeah, I don't know. I mean, I think me streaming this, like it, sometimes it's helpful to say out loud kind of what you're thinking, and also to have people on the other side keeping me honest. Sometimes helps. Dev Souza, what's this playlist? I can, let me see. So I'm using a music service called Pretzel, and it, if I can find, I think the playlist gets published somewhere. Oh, okay. I don't know if I can publish the playlist or not, but if you go to like pretzel.rocks, it's like a music service for streamers that allows you to like basically play music that won't infringe any copyright stuff. So the stream doesn't get taken down or anything. And they have some good stuff on there, but you can like limit it to like instrumental only. And then there's like a playlist called Chill, or like a category called Chill. And I've just been listening through it during my day, and then just adding ones that I like or have like the right vibe. Been adding those to a playlist that I play during the streams. So I've been pretty happy with it. Okay, so it doesn't look like, oh, because I'm just testing that one. I want to test this one. So what this will do is this will end up failing, or like it'll end up generating code that assumes that foo is strictly unstable, which is true. But the problem is that it'll also assume that like a type like like this is strictly unstable, which isn't true yet. So we'll have to like refine that logic, but just to make sure that like this generates kind of what I expect when get stability returns unstable. We're just trying that out. So you can see here that it does. So the test just returned this, which so you can see now that there all of the logic that was kind of generated before is now gone, and that's because we've determined, I guess, that that this function can never skip because foo was considered unstable and it's final, so there's no subtype of foo that can ever be stable. So we know that code would never be necessary. So that's looking good. So basically the next step for us is going to be essentially improving this function and figuring out a good way to propagate that from the front end, which I'll be working on next. I think I'm gonna close down the stream now. We've been going for about 2.5 hours and scheduled for 2. I went for 4 on Wednesday, and a few people, I don't know. I guess were telling me that they thought maybe it was too long. Maybe if you have any opinions, let me know. Especially when I'm just working on the compiler here, I feel like I have enough energy to just kind of keep going. But I'm not sure if that's a good idea. If I just streamed all day, like I think some people would maybe get tired of it or something and feel bad about leaving or something like that. I don't know. Let me know what you think. If I should stream for longer and just not worry about that, or if you'd rather me keep like a standard kind of 2-hour schedule when I say that that's what I'm going to be doing. Curious to know what you all think. But for today, it's a little past noon. I think I'm going to go grab some lunch, and that'll be it. So thanks everyone for tuning in. I hope this was interesting, helpful, all those things. So yeah, appreciate you guys. Guess when you're working on a compiler, in my opinion, you could go longer. Okay, thanks for that, Dev Souza. Okay, you like longer streams. Great. Well, I'll try and get some more feedback from people, but if people seem okay with me streaming for longer and it's not wearing me down too much, then I might consider it. So yeah, I'll think about it. Let me know. You can tweet at me on Twitter or something too if you have more that you want to say. But anyway, thanks everyone. Appreciate you.